All right, so hello everyone, good morning. Welcome to your first lab for CAC 160. So can anyone please confirm me that you can hear me loud and clear, and also you can see my screen?
I can hear you.
All right, thanks. So, okay, I think we can start. Even though this is the first day, the whole session is going to be recorded, and I'll upload that to probably multiple places in user, the default video platform for UCSC. Also, we have a YouTube channel. I'll try to, split the video based on the topics, and then I'll try to upload that to the YouTube channel. That may take a little bit longer. Probably not going to be just after the lab, maybe in one day, but I'll try to make the whole session available in user sooner. Okay, so without further delay, let's start. Okay, so hello again, everyone. You may know me that I introduced myself in the class yesterday. So my name is Fahim. I am a fourth year PhD candidate in the Department of Computer Science and Engineering. I have been TA for CAC 160 4 times before this one. So this is my 5th time TAing for CAC 160. And so this is again going to be a fully online course. So we will not have any lab, in-person lab, even though I did that before at some point when this was not an online course. So everything we're going to present in this lab session, which is going to take place on Monday, starting from 11 a.m. to 1 p.m. And then I will upload that to the video platform, and you'll be able to see the video later at any time. That's why we have only one lab, since that is accessible anytime. So today we are going to introduce some HTML and JavaScript. So this is a WebGL course, right? So OpenGL is the language for computer graphics, the usual language. So OpenGL can be used with a various number of languages, right? So you can use OpenGL with C++, Python. We are going to use a lightweight version of OpenGL, which is called WebGL, that you can run on your web browser. Since running full OpenGL can take more effort because there are various types of platforms like Windows, Apple, and various type of graphics devices, it can be more management to run the full OpenGL, right? We don't have those issues with this browser-based WebGL. So also these are the topics I'm going to discuss today, and the first thing I'm going to do is going to introduce you to assignment 0. What are the requirements, what are the tasks you need to do for that, and then I'll talk about HTML, a little bit of CSS, which is sort of optional, and then web server, which is also going to be another requirement for submitting your work. And then finally, JavaScript, which is going to be our container script for doing everything with WebGL. So JavaScript is going to be the language that you are going to use a lot for all of the assignments, including the last one where we are not going to directly use WebGL, use a third-party library that is called 3.js. Still, the programming is done. A lot of the programming is done using JavaScript. Okay, so let me introduce assignment 0 first. Then I can start with some of the logistics. So, you know, my name, I have my name here and my email address here. So if you have a question, you can send me email using this address, mostly about the lab. If this is a very common question, then probably post that on Piazza, because then other people will be able to see the answer. So we have a Piazza page. Piazza, so the link is here. Then I'll have office hours, that is here. 2 hours on Tuesday, which is today, from 3 to 5 p.m. and 2 hours on Thursday, which is 11 to 1 p.m. So 2 different times of the day. One is earlier, one is later. So hopefully wider group of people will be able to reach me. So we have another TA, Eric. He will also have office hours. I think he'll announce more about that on Piazza. So let's move to the assignment 0 and start talking about what we need to do. So this is our assignment 0. Here you need to create a vector library for your graphics, for drawing some graphics, right? So some very simple graphics. So we are not going to use full-fledged WebGL in this one, since sort of obvious from the name, right? So assignment 0, not even the first assignment. You'll learn how to create object-oriented graphics projects in JavaScript, and then here you draw a canvas element using a 2D context, right? So that's sort of the thing. Starting from assignment 1, we are going to start building 3D world using some simple blocks and other objects. But this one is 2D, so we are going to use a 2D context, which is called canvas, and review fundamental concepts of linear algebra, which is part of also homework 1, where you will do some reading. And the task you're going to do is based on your previous knowledge of linear algebra, like basic, how to do basic vector operations, dot product, cross products, those things. So the nice thing about assignment 0 is this has been developed for a long time. So Lucas started working on this one, then we continued working on this. We used this for a long time. The concept is very well explained, what you need to do. So follow the instructions very carefully, line by line. And also you can see we have a very nicely explained rubrics here. So this rubric is telling you with each of the tasks you're going to get this much of the points, right? So 1 point for the first thing, just for setting up, then drawing a red vector, 1 more point. So that is also mentioned with each of the tasks. For example, for task 1, you have 1 point. You just need to do the setup, right? Probably I'll show you the setup today. So this is 1 free point. Then you should follow the instructions line by line and continue building your code. So the code is sometimes you're going to build it on the top of the previous one. For example, the first one, you have a rectangle that will show up on the screen. Eventually that will be removed, right? So why is that? Because you're going to replace that with something new. And once you replace that, if you run the code, the output will not show the previous stuff anymore, right? For the rectangle will not be visible anymore. It will not be there anymore because you're going to replace that with something else. Now, what is going to happen with the grading? Since no one is going to see the first task, but yeah, we'll know that since you already have the later task, you started with the first one, so you don't have to worry about that one. You just need to submit one version of your code. For each of the tasks, no need to submit multiple files, only one file. And how to submit the files, that is also explained here very nicely, right? So for the computer graphics, you actually have to submit in two places. First one is in Canvas. On Canvas, here the instruction is telling you how to create a zip file. The zip file will contain all your resources, which include the HTML code, the JavaScript code, and also if you have some images and other stuff. Then submit the zip file on Canvas, which is primarily for the grading purpose. And then you have to host your submission to your UCSC portal. Right? I believe this is also called the timeshare, the Unix timeshare. So using your UCSC ID, you can access to this Unix server, then host your web page, and then send the link. So this is the way how you share your link for that specific project or assignment. So there is one advantage of this one. So you can make your work public, so other people will be able to see it if you want to, given that you shared your link with them. And also we have contests for most of the assignments, not for the first one because this is too straightforward. This is more like a warm-up task. So for the next ones, you will have context, and in the context you are going to share your link to the group of people who is going to vote for you. So there is a submission guide. Follow this one carefully. This is a simple text file, how you need to submit on Canvas, then how you need to submit the live host submission on the timeshare. Sometimes that there are issues, and we also have solutions for this, like 4 or 3 forbidden error, this type of stuff. So hopefully this is a complete guide how to make your submission. But still, if there is any problem, we'll be there with the office hours and definitely come to us for help. Okay, so instead of going through each of the requirements or each of the tasks, what I'm going to do, I'm going to show you my solution so that you can see how you can use the final product of this task, right? So after the step 8, you will have this fully interactive user interface where you can create vectors, mostly 2 vectors, and do some operations. So let's do that first. I'm going to show you the solution I have. So this is the assignment 0, right? As you can see, even though there are animated screens here, which is sort of obvious, but here you can see how exactly we can interact with the interface. So if we have 2 vectors, again, I am mentioning that because our work is in 2D, so we don't need a z-axis, right? So our vectors only has 2 components, the x and y components. So we are going to draw vectors using the x and y components. So we have 2 vectors, we can draw the vectors. Then we can do these operations, which is sort of outlined for each of these steps. For example, step 3 is how to draw the vector 1. Step 2 is draw a second vector. Step 4. Step 5 is add your web page, add your interface for getting the simple operations like addition, subtraction, division, multiplication, and then add some more complex operations like magnitude, then angle between. The last one is the cross function, the cross product. We also have a dot product here. So let's take a look. If I want to draw a vector, let's draw a first vector, maybe 5 and 10. And then I can draw another second vector. Let's go with -7 and then 15. If I draw this, you can see this is going way outside of the screen, right? Which it is not very expected. So you can always mention the range here. how you're drawing your vectors. So for this one, we are expecting vectors which can be smaller than 10. So let's go with smaller ones. So -7, then we can do -3, 8. So this is more visible, right? You can scale down your lines and then you have larger values that you can take here. Also, another thing is you can always use something like this, like 4.5, that will make things smaller, right? So floating point values should be valid for running in your interface. Okay, now you can do some operations, right? Like for example, you can do add, and then if you draw, you can see the addition, the new result here, right? Now we have a scalar, and why do we need the scalar? So the scalar is mostly for the, where do we have it? Find the scalar part. I think it's explained here somewhere. We have a draw function, then expected results. So this is telling you to draw the vector 1, then the add sub operations. Okay, I guess the scalar is not clearly defined. So the scalar is going to be valid only for some operations, right? Okay, let me explain that later. So this is add. If we subtract, it will be a different one. Every time you can see when you add something, the previous one is gone, right? So the result of the addition is not here. So we have a clear. That is also mentioned here in the step 2, I think. Yeah. So clear the canvas. Every time you do something new, you should always clear the canvas so that the old result is not there in. So then we have this divide, which is not going to work with this. So if I go with this, now you can see the divide, right? So that's why you need the scalar. And for the multiplication, for the simple multiplication, not the dot product or cross product. So if I do a multiply, that is also going to multiply the whole thing. Now this is way too larger, so let's make it much smaller. So now it's smaller, right? You can see the results. So the scalar is needed for these two operations. And then we also have magnitude, which will return the value of the magnitude. So how you are going to see the magnitude? You're not going to see anything here, right? So magnitude is a value. You cannot visualize that. So that's why we need the console. So if I, for the Windows, or I can do this inspect. So I'm right clicking here and clicking on the inspect. It's showing me the additional options. So if I go to the console, you can see. Let me run it again. The magnitude is shown here, right? So some of the output, they're going to be text outputs. Normalize again. If I draw this, you can see this is now divided by the magnitude. So that's the definition of normalization. Then angle between, you can see the angle between the two vectors, which is 167 degree here. This is in degree, not in radian, so you have to convert that depending on how you are implementing that. Then the area is about, if you draw a triangle with these two, then how is going to be the area? So this is going to be a very narrow area. Maybe let me move this a bit. Now the area is going to be longer, but maybe make this. Yeah, this is better. So now we'll have this area of the triangle here. So if I draw, it will show me the calculated area here. So a lot of the later results, they are going to be shown on the console. So these are the requirements, and this is the quick demo what you can do. And as you can see, there is no option for dot or cross products here, right? Why do we need that? That is sort of explained here. You do need to use the dot product and the cross product for calculating things like angle between. You're going to need the dot function and then the cross function for the area of the triangle, even though we are not explicitly giving the option for those things. So this was the introduction to the assignment 0. So before moving on to the HTML part, is there any question that I can answer about assignment 0?
Yeah, I have some more of a question.
Sure. Go ahead.
I assume it's gonna be answered later. But is there a good like IDE we should be using, or just like Notepad?
It's up to you. So I'm going to show you some code soon where I'm going to write HTML and JavaScript. So I'm going to use Atom, which is, I think, cross-platform. So you can use that on Windows and Mac. And then there are other options. I would say it's up to you. So which IDE you are comfortable with, you can use that. So there is no preference or requirement for, at least for this course, because we are going to run everything on the web browser. So for the web browser, my recommendation is to use Google Chrome, because Google Chrome has better compatibility with these libraries, and also that is cross-platform, right? So I guess test your code on Google Chrome before submitting it to Canvas. That's my recommendation. But for the IDE, I have no strong preference. Atom is good because that is developed by GitHub. So if you want to use version control and save your code, then that may be a good match for your work.
Cool, thank you.
No problem. So any more question?